Hi, this is Open Up Resources, Algebra 1, Unit 1, Lesson 9, Geometric Meanies. Remember in Lesson 8, we looked at finding the common difference when we had an arithmetic sequence. Today we're going to look at finding a common difference common ratio with a geometric sequence. So let's start with the jump start. So it says, which one doesn't belong? Choose the number that doesn't belong with the others and explain your thinking. Hint, consider the factors for the numbers. So we're looking at factors. So I see this first one ends in a 5. So if I take 1875, and I divide by 5, I get 375. So I'm going to go back over here, and I'm going to write in 5 times. Let's go ahead and just keep going down. Divide by, that's got another 5 on the end, so let's divide 375. 75. Okay. If I keep going, 75 divides by 5, 15 times. And 15 is 5 times 3. Okay, so I do 5 times 5, so 25 times 25 times 3 gets me 1875. Let's try 405. Look at that. That one's a 5 as well. All right, so 405 divided by 5 is 81. So 5 times, and I know 81 is 3 times 3, which is 9, times 3 times 3, which is 9. So 9 times 9 is 81. 81 times 5 is 405. Okay, let's look at this one. Ends in another 5. 1215 divided by 5, 243. Well, since the other one had both of them had a 3 in it, let's divide by 3. That one works. So, and I think it was back to 81, wasn't it? 81. So I know 81 is 4 more 3s, 1, 2, 3, 4, and the 15. Okay, 40 is 5 times 8, which 8 is really 2s. And then 1280, let's just divide by 5 on this one. 1280 divided by 5, 256. Oh, sorry. So when I divided by 5, 256, I don't think that divides by 3. Nope. 256, I guess we'll have to divide by 2. Is 128. So 128 divided by 2 is 64. 64 divided by 2 is 32. Divided by 2 is 16. Divided by 2 is 8. Divided by 2 is 4. Divided by 2 is 2. 1, 2, 3, 4, 5, 6, 7. So let's see what 2 to the 7th times 5. Let's see if we did that one right. 2 to the 7th equals times 5. Oh, we got to get one more in there. 1, 2, 3, 4, 5, 6 must be 8 2s. Because we need to get 1280. There we go. So 2 to the 7th. Times 2 times 5. There we go, 1280. All right, so if we look at these, this one equals 3 times 5 to the 4th. This one is 5 times 3 to the 4th. This one's 5 times 3 to the 5th. 5 times 2 to the third. 5 times 2 to the eighth. So really, all of these probably have something a little different. I mean, this one, these two both have, all of these have a 5, single 5. This one has multiple 5s, so that makes A different. B, I don't know, these two both have 3s. These two both have 2s. These two are even. These 3 are even. Those 2 are odd. Probably the one that is the most doesn't belong is A, just because it's the only one with multiple 5s. All the rest have 1 5. I'm sure we can go dig deeper and find stuff, but that's good enough for now. All right, so now we're going to find our geometric sequences when we have missing terms. So we need to figure out our common ratio. So each of the tables below represents a geometric sequence. We're going to find the missing terms and show our method. So what I did up here, I'm going to back up just a hair, is I didn't just do factors. I actually went down to the prime factorization. I'm going to go ahead and type that in here. Prime factorization. What that means is I took these down. These are all prime numbers, 5, 3, 2. I broke it down to the smallest numbers that I could multiply by each other to get this number. So we're going to think kind of on those terms as we're exploring these today. So for our first sequence, 3 times what equals 12. So let's see. I'm going to go to drawing. And 3, so just like our other one, we notice we have 2 little bumps here. Well, 3 times 4 is 12. So if I do 3 times 2, that's 6. 6 times 2 is 12. So there we go. 6 is my missing answer. Is it the only answer? I don't know. Could I have anything else in there? Let's think about this. When I'm multiplying, I rarely can have positive or negatives, right? Well, if I do 3 times negative 2, I get negative 6. 6 times negative 2 equals positive 12. Well, I'm still starting with 3. I'm still ending with 12. So is this my only answer? No. Negative 6 could also be my missing term. I can multiply by 2 or negative 2 and make this sequence. All right. I actually had 2 answers for this one, 6 or negative 6. I'm going to put negative 6 or 6 could be my missing. There we go. All right, let's look at our second sequence. Same idea. So 7 times something times something times something gets me 875. Let's think of this in terms of our prime factorization. 7 times, this is my common ratio, right? Ratio times ratio times ratio equals 875. Well, 7 times 7, r cubed, equals 875. How would I go to get the r by itself? Well, first I got to get rid of the 7. So if I divide both sides by 7, I get r cubed equals, let me get my calculator out here, 875 divided by 7. 125. 125. So now what times itself 3 times equals 125? Now I can either think of it in that terms, or I can do what's called a cubed root. Just like, I'm going to go over to the left here. If I have 3 squared equals 9, then I can take the square root of 9. What times itself equals 9? Well, 3 does, because 3 times 3 is 9. Well, same thing happens with roots. I can say the cubed root of 3, those cancel. What I do to one side, I got to do to the other. But I'm still thinking in terms of what times itself equals 125. Well, I know that 5 times 5 is 25. 25 times 5 is 125. So R equals 5. So one way I'm going to show you this on a calculator. I think I've got it on this guy. Oh, nope, I'm going to have to make him bigger. Let's see if I can find my, oh, I don't know if this one has it. My functions. I don't see my functions on here. This one doesn't have the option to do it. You see how this one has the root? You look for one that has a y here. So then you can do the same thing. I don't know. I thought my... Nope, those guys aren't going to do it. That's not going to do it. Oh. Sometimes it works when you... Let's see if I can get a different one. That doesn't have enough options. It's got my... Let's see if my... Will graphing do it? Nope. Sometimes when you make some of these bigger, nope, it just really makes it bigger. Well, shoot. I can't show you on this one. I don't think that's going to help too. All right. Well, we're going to go with what we've got. So, we won't be able to do it on here, so I'm just going to have to figure it out in my head on these. All right. So, are the missing terms identified the only answers? Well, I have 3, but I said 5s. Oh, so I got to fill in my boxes. 7 times 5 is 35. 35 times 5, let's do that. 5. Oh, what did I do? 35 times the world. Now I've got funny things going on. 35 times, I don't know what I did. Clear. Okay. I think I just messed up my calculator. Okay. I don't know what's going on. It's 35 times 5. Let's just close this out, start over. There. 175. There we go. 175. All right. And then 175 times 5. Do this one in my head. Yes, that works. All right. So are there any missing terms that could also, other ones that could be it? Well, or are these the only answers? Well, let's see. If I did -5, -5 times -5 times -5, 3 negatives would get me a negative answer. This one's positive. So the answer is yes. These are the only missing terms. And the ratio is 5. All right. Let's go to 3. All right, so missing terms. On here, we have 1, 2, 3, 4 that I'm multiplying. So 6 times ratios 4 times gets me 96. Well, 4, just to start with, if I have 4 negatives, I'll still end up with a positive. So we know this missing terms. The only answers, no, we're going to have a couple of options. But let's solve what we got first. 6r to the 4th equals 96. So, first of all, let's see. I'm going to need to divide by 6. Get my 6 out of there so I can get my r's by itself. So r to the 4th equals 96. And, oh, not 96. Getting distracted here. And to pull out a different calculator. So 96 divided by 6 is 16. 16. So now I need a 4th root. I don't need 3 numbers multiplied by themselves to get 16. I need 4 of them. So what times itself 4 times will get me 16? Well, I happen to know that 2 times 2 is 4. 2 times 2 is 4. 4 times 4 is 16. So it's 2. So 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. And then it's 96. But here's our thing with that negative. Only answers no, because a negative times a negative times a negative times a negative still gets me a positive. So if I did it times negative 2, 6 times negative 2 is negative 12. Negative 12 times negative 2 is positive 24. Positive 24 times negative 2 is negative 48. Negative 48 times negative 2 is 96. So these are my options. No, we can multiply by 2 or negative 2. So the 12 and 48 could be both positive or both right? Can't be one or the other. If we multiply by the negatives, they're both negative. So we multiply by the positives, they're both positive. All right, 4. So let's see this one. Let's go back to our purple. 1, 2, 3, 4, 5. So I'm just going to go ahead and go 4 times r to the 5th because I know I'm going to have 5 r's to get 972. So it seems like my first step is to get rid of this 4. Got to divide by the 4. So r to the 5th power, let's see what 972 is divided by 4. 243. Equals 243. I have a feeling that r to the 5th is going to be a 3, but let me double check this. So now I need a 5th root because I need 5 numbers times itself, or number times itself 5 times to get me 243. And it is a 3. 3 times 3 is 9. 9 times 9 is 81. 81 times 3 is 243. So, and then, are these the only missing terms? No. Negative times a negative is a positive. Positive and a negative is a negative. Negative and a negative is a positive. Positive and a negative is a negative. Nope. This is it. So 4 times 3 is 12. 12 times 3 is 36. 36 times 3 is 108. And 108 times 3 is 324. So are these the only terms? Yes. We can only multiply by 3 to make this sequence. All right. What's the next page? Describe your method for finding the missing terms in these geometric sequences. Well, really what we did was, if we kind of go back and look at our pattern, here we took the last one divided by the first one, and then we took a root by how many jumps. Last one divided by the first one, the root was how many jumps. Last one divided by first one, root was how many jumps. Same thing here. If we do 12 divided by 3, that's 4. The square root of 4 is 2. So that's pretty much our method, isn't it? Divide the last term by the first term, then take the root of how many jumps were between the two numbers. How can we tell if there'll be more than one solution for the missing terms? All right, let's go see if there's a common factor, something in common with the missing. Let's see, this one had 5 jumps and there was only one option. This one had 4 jumps and there were 2 options. 3 jumps, 1 option. 2 jumps, 2 options. Okay, so what I'm seeing is if we have an even number of jumps, we have 2 options. If we have an odd number of jumps, we only have 1. The number of jumps are even, and the common ratio could be positive or negative. If the number of jumps is odd, number of jumps is odd, then the common ratio is 1 number. All right. So here's some bonus. Let's just go ahead and do these since we kind of have the idea of what we're doing. So without the boxes, I have 1, 2, 3, 4 jumps. So let's try our method. 324 divided by 4 equals 324 divided by 4 is 81. 81. And I have 4 jumps. So I want the 4th root of 81, and that equals 3. So 4 times 3 is 12. 12 times 3 is 36. 36 times 3 is 8. I think I just did this one, didn't I? 36 times 3. 108. 108. Or, because it's an even number, times a negative, it'd be negative 12 or negative 108. All right, an arithmetic one. Let's go back to these arithmetics that we did last time. So an arithmetic one, we subtracted 324 minus 4 is 320, and then we divided 1, 2, 3, 4 divided by 4. Well, 4 goes into 32, 80 times. So this is 80. And then 80 plus 80 is 160. 160 plus 80 would be, 84. Whoops. You got to add the 4. Plus 80 is 84. 164. 244. 324. All right. Takeaways. Given two terms in a geometric sequence, let's finish that out. We are going to take first term times the ratio to the number of jumps equals the last term of the sequence. We kind of set up an equation like that, didn't we? R to the number of jumps, our common ratio to the number of jumps, equals that sequence. So one way we could write this, if we're going to put this more as a and our equations in the terms, the answer to 1 times r to the n minus 1, right? Because we need however many terms we have, our jumps was 1 less, equals our answer. So that's kind of the equation way of writing it. So let's go ahead and just put some more words to this. So use the equation to find the common ratio and multiply by the previous term to get the next term. So the same idea as we've been doing. We set up our equation and then we solved. All right. Retrieval. Let's see. Find an arithmetic sequence with an initial value of h if 1 equals 13 and a common difference of 9. So it looks like I need the 1, 2, 3, 4, 5. So h of 1 is 13. It tells us this right here. So 13. Common difference is 9. So I'm going to add 9 to get 22. Add 9 to get 31. Add 9 to get 40. Add 9 to get 49. That works out pretty well. All right, next. The arithmetic sequence, the answer is the previous one minus 4. And I start with 53. Well, here's that again. Here's 1. 53. And I'm going to subtract 4 each time. So 53 minus 4 is 49. Minus 4 is 45. Minus 4 is 41. Minus 4 is 37. There we go. All right, use the given recursive rule to find an explicit equation for the same function. All right, well, I start with 7. So f of n equals 7. And it looks like I'm going to add 32 each time. Let's go ahead and use different colors for this. Plus 32. And since I'm doing a 1, I need to take away 1 because the first term I don't need, the 7 doesn't need a 32 added right away. It's the next one that does. So there we go. And number 4. Let's see what number 4 is. Same idea. Let's go ahead and use our same colors. F of n equals, starting is 63. I'm going to take away 8 over and over. but I'm starting with the first term, so I need to have an n minus 1. There we go. And that is it for today. Thanks for joining us, and we will see you next time.